Okay, in this problem, they want us to prove or disprove. So prove or disprove, meaning we don't know if it's going to be, true or false. But they want us to prove or disprove, meaning to prove wrong, that the point 2, comma, 2 root 3 lies on the circle centered at the origin and containing the point 40. So they want us to prove it. So let me break down this problem here. So here it says containing the point 40. So containing the point 40 meaning that the point is on the circle. So it's on the circle. The point is on the circle. So if I look at the point 40, this point was already plotted for me. But 40 is located here. And I can see that this point is in fact on the circle. Right? We can see that it does contain this point. And, especially because they're telling us that it's on the circle, it contains it. So we can guarantee that this point is on the circle when they say it contains the point. The other fact they told us was that the circle is centered at the origin. The origin is a word to describe this right here, where the x-axis and the y-axis, where they both meet, which is here. That's the origin. So you'll notice sometimes we have like a italicized O, like an uppercase O, and that represents the origin. The origin has coordinates 0, 0. So the coordinates are 0, 0, and they're telling us that the point 40 is on the circle. And when I look at that, that also tells me another fact that they didn't specifically tell me, but it does let me know that the radius of this circle is the distance, which is basically the distance from the center to any point on the circle. I can see that this distance here is 1, 2, 3, 4, because we know 40 is on the circle, and the distance from here to that would be 4 units. So when you read a problem, you can't just read it quickly. You really do have to take the time to see what information is given to you. You want to organize it as much as you can and see if there's any other implied information. So like other things that we can infer. And we can see that the radius, even though they didn't tell us directly, but we could figure out the radius because we know that that's 4 units out based on the given information. So that's one thing that I want to put a star next to, because that we came up with on our own. So again, the information they give you, you have to take the time to see what new information you could create. So that's very important when you're trying to do, problem solving. So you really have to, have patience for that. Don't rush into it, which is a common mistake people do, is they just want to get to a quick solution, but you don't want to do that. Okay, so now going back, it says prove or disprove this point lies on the circle. So they want us to prove that this point here lies on the circle. So a point has x and y values. So x comma y, right? Like the point 40, this is my x value, this is my y value. So this 2 here is my x value, and then 2 root 3 is my y value. So if I were to plot that point, it would be right 2 and up, we don't know, but we're assuming if it's a point on the circle, then this coordinate would be 2 comma 2 square root of 3. Right? I can see that my x value here, my x value is 2, and if I go up, that's the only other location I can go to on this circle. If I would go down to this point, that would be a negative y value, but the y value here is positive, so that's the coordinate there. So we want to know, is this on the circle? So when they say lie on the circle, you want to check, is that point in fact on the circle that we're looking at? So we're going to use the other skills that we practice in the other parts, and we're going to apply that in this problem. So one thing that I noticed is that I can use Pythagorean theorem here. So what I'm going to do is I'm going to connect the origin, the center of the circle, to that point, and I'm going to bring this straight down. I'm going to make a little right triangle here. So I created a right triangle. I know this is a right angle because any any vertical line and horizontal line on the coordinate plane always forms a 90 degrees. So since this is a vertical line and a horizontal line, I know that this right here is 90 degrees. And if I look at this triangle, I actually know some of the parts, some of the lengths. If I look at this part here, that has length 2. And actually, I can see that my drawings is getting kind of crowded now. So I'm going to extract this. I'm going to move it over here. So I'm going to redraw that right triangle. It doesn't have to be perfect, but I know that that represents that triangle there. And now I know that this was my right angle, and then the distance from here to here is 2 units. And if you pay attention to this part here, the distance from here to here, I don't know if you guys noticed, but when you have a circle, all the radii have the same length. So they're all congruent. So I know that the radius of the circle we mentioned earlier was 4 units. And since this is this segment has an endpoint at the center and on the circle, I know that this is the radius also. And we already know the radius is 4 units, so I can label this as 4. So that's one of the key things, and that's why it's important to recognize the radius of the circle and that all radii are congruent. So that's why we're able to say that this has to be 4 units because the endpoints are on there. And then we don't know the length of this side, but with Pythagorean theorem, we could figure out what that length is and see if this is going to work out. Well, actually, let me take that back. So we could actually get this length now. If you look at the distance from this point to this point, I can see that this distance is simply, if I look here, this is just my y value, my output. So when I went right 2, I had to go up a certain amount to put that point there. Well, how much did I go up? Well, if this point is in fact on the circle, that means that it went up 2 square root of 3. So that's the length from here to here is 2 square root of 3. So I'm going to write that 2 square root of 3. And just to reiterate that, like using like simpler numbers, if I plot a point, so let's say this is 1, 2, and then 1, 2, 3. So if I plot, this is my x value, here's my y value. So if I go right 2 and up 3, that's the coordinate of that point. And you can see that if I were to draw the length of this segment, well, the length of this is simply the output, this value here, it's 3. Because I have to go up 3 units in order to plot this point. So I'm using this idea to get the length of this side here. That this here is 2 square root of 3 because to plot this point, we have to go right 2, and we're assuming to get on the circle that we have to go up this amount. So that's what we're going to check now. Is that in fact the amount that we moved up? Because we're trying to prove again that if this point's on a circle. So let's see. Is it on the circle? So if it's on the circle, we said this is a right triangle, so assuming that this length is correct, then Pythagorean theorem should work if this is in fact a right triangle. Right, let me put the radius here, what we said was 4. So we want to check, is this the correct length to get us on the circle? So for that right triangle. So Pythagorean theorem, I can make squares off of each side. So I'm going to do that. They have to be drawn perfectly, but these all represent squares. So since this side was length 2, I know this side has to be length 2 as well. So the area for this square would be 4. If this length is 4, that means this length has to be 4. So the area for this square would be 16. And if this length is 2 square root of 3, that means this length is also 2 square root of 3. And the area would be, I have to multiply these two numbers together. So let me move this aside real quick. And let me group this. So let me do the work here. And I want to see what's 2 square root of 3 times the 2 square root of 3. So for the work for that part, 2 root 3 times 2 root 3. Well, I know that basically everything here is multiplied together, so I'm just rewriting it. And then we have here, I'm going to rearrange it. I'm going to use the commutative property where I can rearrange the order. So anything that's not in square roots, I'm going to multiply those two together. And the square roots, I'll place those next to each other. Now I have here 2 times 2, which is 4. And then we have square root of 3 times square root of 3. I can combine those under the same square root. And we have 4 times the square root of 9. I know the square root of 9 is 3. So 4 times 3, I get 12. So that's the area for this square. And if this is a right triangle, we know that the areas of the squares that form your right angle should add up to the larger area. And I can see here that 4 plus 12, which are the areas of the squares that form this right angle, is in fact equal to 16. So that is true. Since we know that these two squares, or those two areas, add up to 16, then I know that the problem that we were working on before, so let me move this out the way. So I know that this problem here, we know we do have a right triangle, so I know that this is in fact a point on the circle. So I would say yes, 2 comma 2 root 3 is on, or let me use the same exact words that they use, so it lies on the circle. So yes, 2 comma 2 root 3 lies on the circle. So that's my answer. It is in fact on the circle. And if we had the triangle such that that relationship didn't come out to be true, where the areas added up to that third area, so if the Pythagorean theorem, the relationship does not show to be true, then we know that the point does not lie on the circle. And that's how you would either prove or disprove a point lying on a circle, giving the point that it contains, and if it's centered at the origin.